Hello and welcome to this series of talks on always-on technologies delivered to you as part of Microsoft Virtual Academy. My name is Sunil Agarwal. I'm a Principal Program Manager with SQL Server team, and it is my pleasure today to talk to you about active secondaries. Active implies the ability to do some meaningful work on your secondary replica besides just keeping up with the primary. If you look at a secondary replica in a typical database mirroring kind of a configuration, secondary replica is only using less than 5% of CPU cycles and less than 25% of IO cycles. So you have 95% CPU and 75% IO cycles that are just going waste. And what active secondary is providing is the capability to use those cycles to do some more meaningful work. This presentation we have divided into two parts. In the part one, that is this presentation, I will describe how you can use your secondary replica to offload your reporting workload. In the part two, Kevin Farley, he will describe how you can use your secondary replica to offload your database and transaction log backup. The agenda for this talk is very straightforward. We will first examine how people do reporting workloads in common high availability configurations, the value proposition of readable secondary, and then we will look into a high-level architecture, and then the impact of running read workload on the high availability as well as on the throughput of your primary workload. And we will also examine what is the performance of running the reporting workload on the secondary replica. I'll have a short demo, and then I will describe at a very high level how your secondary replica can connect to how your reporting workload can connect to secondary replica. So if you look at reporting workloads today, and let's first look at database mirroring high availability configuration. As you know, you cannot really run any workload on the mirror. So what DBAs do, they run their reporting workload on the primary node. Now the challenge with that is the primary workload is going to compete for resources with the reporting workload. Reporting workload is going to take CPU cycles, it's going to do IO bandwidth. So your primary workload is competing, thereby it can slow down. Now in a worse situation, the reporting workload can take locks. For example, it can take shared locks that can cause blocking in your primary workload. Now, the impact of that could be quite severe for your customers running on the primary workload. So what most administrators do, they try to schedule the reporting workloads in off-peak hours. As you know, in today's environment, there is not really a off-peak hour. It is a 24/7 operation. So this poses a huge challenge to the administrators on running the reporting workload on the primary node. Now there is a solution that you can create a database snapshot on the mirror, and you can run your reporting workload on the mirror. While this works for many customers, but the challenge of running a reporting workload against database snapshot is that it is point in time. So if your reporting workload cannot tolerate data latency beyond, say, few minutes, then database snapshot is not a solution for you. So that's the challenge people face in database mirroring configuration. Now let's look at another common configuration, that is transactional replication. In a transactional replication case, you have a primary node and you have one or more subscribers. And what you can do is you can run your reporting workload on those subscribers, and you can have a good scale out story that way. The key benefit of transactional replication is that you can create your reporting specific indexes on those subscribers. So you can get a much better performance of your reporting workload. But the challenge with replication is that it is hard to set up. And then if you have a high transactional throughput, replication does not scale as well. So as you can see, in today's environment, 2008 R2, customers are using the current technologies to run their reporting workload, but there are challenges. The goal of always-on technologies is to make that job easier, especially with a readable secondary. So if you look at, I'm going to describe a very simple configuration like you have database mirroring configuration where you have a primary node and a secondary node. Think of always on readable secondary as a advance or the next generation database mirroring. I think that sort of makes it easy to understand what is going on. So the difference here that you will see is it looks like database mirroring. You have a primary node and you have a secondary node. That is secondary replica. We call it our secondary replica. It's like a mirror. The difference is that you are able to run a reporting workload on the mirror. Now the latency that this reporting work will see is whatever the transaction log records that have been applied. And the key point is your reporting workload will always see some latency. We expect it to be within few seconds. But if your workload, the reporting workload, cannot tolerate any data latency, then you have no choice but to run on the primary replica. But as we have seen with majority of reporting workloads, they can tolerate some latency. So it makes perfect sense to run that reporting workload on the secondary replica. Now the interesting thing happens is, just like in the mirror case, when you have a failure, the primary becomes a secondary and the secondary becomes a primary, your primary workload can reconnect and it is automatically redirected to the right primary. Same thing holds here for reporting workload as well. So let's say I have a crash on the primary node and the polarity switches. And now if you reconnect your reporting workload, it will know automatically what is a new secondary, and it will go and run the workload over there. One thing to notice that in a database mirroring or always on technology, it is based on transactional logs, and it requires that both primary and the secondary have to have the same physical state. That means you cannot really create a reporting specific indexes on the secondary. The index has to be created on the primary. So in that sense, it is not really a replacement of transactional replication, but it offers a good way to run your reporting workload on secondary hardware, thereby leveraging those cycles available to you. Now let us look at how the information flows from the primary node to the secondary node in the form of transaction log records, and how does the redo thread that is running on the secondary node applying those transaction log records. And this will give us a good understanding why there's a latency in the data when the reporting workload is running on the secondary node. So primary workload is generating transaction log records on the left side, and it is filling the log cache with those log records. Now when the log cache becomes full, or the primary load issues a commit operation, at that time the transaction log records from the log buffer are flushed to the log disk to make it persistent. Now this, since we are running in a always on configuration, we have a second component which is log pool. In that case, what happens is when the log cache is being flushed to the log disk on the primary node, those log records also get copied to log pool. The log records in the log pool are read by a thread called log capture, and its job is to read the log records from log pool and send to the secondary replica. If there are multiple secondary replicas, there is one log capture thread for each of those replicas, and this is good because you want to send the log records across multiple replicas in parallel, not sequential. Now let us look at what happens on the replica, the secondary replica. So there is a thread log receive that is running on the secondary replica. It receives the log records from the network, and it starts writing to the log cache. While the log records are being written to the log cache, there's a redo thread that is always running on the secondary replica. It is reading those log records and applying those changes to the data pages and the index pages in the database on the secondary to bring it up to date with whatever has happened on the primary. As you can imagine, the redo thread needs to read pages and apply the change. So there is some extra work that redo thread has to do to make those changes available on those data pages. Now, when the log cache on the secondary replica becomes full, or it receives a commit log record, it hardens the content of log cache onto the log disk on the secondary replica. Now, if the secondary replica was configured to run in sync mode, it will send an acknowledgement on the commit to the primary node indicating that it has hardened the transaction, and so it is safe to tell the user that the transaction is committed. And because we have hardened the logs on the secondary, there's a guarantee that in case there is a failover, there's no data loss because we have all the logs. Now, while this is going on, the redo thread is applying those transaction log records, and it is running independently of how log records are being generated on the secondary or being copied and persisted. So in general, what we have seen is the redo thread is running few seconds behind. If, for example, it can become behind, say, a few minutes, in that case, those log records are not available in the log cache. In that case, it will pick up those log records from the log disk, and that is what is shown in the dotted line on the right side of the slide. So far what we have seen is that you can run your reporting workload in AlwaysOn on the secondary replica. There is some latency, and it provides automatic failover in case the primary secondary node changes the polarity. Now let us look at what is the impact of running a reporting workload on the high availability and on the performance of your primary workload on the primary node, and also what is the performance of running a reporting workload on the secondary replica compared to if I had run that reporting workload on the primary node. So first thing, in this picture, in this slide, I'm showing you just the secondary node. Let's not think about primary node. So as I had explained in the beginning, that typically the secondary replica, if it was not doing any reporting workload or database backups, it is taking less than 5% of CPU cycles and 25% or so on IO cycles. Now, obviously, it depends on your workload. So let's assume 5% of CPU and 25% of IO cycles. Now, the reporting workload typically are IO bound, right? They take a lot more IO resources. So if you have a reporting workload that is taking 90% of IO cycles, and notice redo wants 25%, so there is a competition. So redo thread is not going to compete to get those IO cycles, and sometimes it will lose out, right? So what happens is it will slow down. So the raw log apply rate, the way the rate at which it was applying the transaction log, there will be some slowdown. What it means is that you have a lot more transaction logs to catch up on. It has two impacts. Number one, your reporting workload will see a lot more latency, right? Because the redo thread is not able to apply all logs at a faster pace. And then there's an impact on the RTO, the recovery time objective. So in case, let's say because of reporting workload, redo thread fell behind, say 5 minutes. Now, if the failover happens, after the failover, we have to catch up those 5 minutes worth of log records before we can make that replica available for primary workload, assuming that replica was converted into primary replica. So that is one impact. So impact on the RTO, and there is impact on the latency. You can mitigate this thing in two ways. First thing is, what you can do is you can control the IO cycles taken by the reporting workload. Unfortunately, in this release, we do not provide a resource governor solution to allocate a fixed IO cycles, number of IO cycles to reporting workload. So we cannot say take only 60% of IO cycles. However, we can control the CPU usage by this reporting workload. So by giving less CPU to this reporting workload, you can indirectly control how much IO cycles it will consume. So it's an indirect way, not the perfect solution, but it is there. Other solution that some of our customers have done is, if they have two replicas, one is in sync replica and one is in async replica, what they do is they can does the reporting on the async replica, and the sync replica is running without additional overhead. So in that case, they are able to guarantee the high availability, no compromise on the RTO, while still able to offload the reporting workload on the async replica. Now, obviously, this needs 3 nodes, a bit more expensive. So those are the choices you have. So that is one aspect of running a reporting workload and the impact on the high availability, namely in terms of RTO. Now let us look at a different aspect. If you are running a reporting workload on the secondary replica, and for now let us assume that it is running under repeatable read. Typically you do not run your reporting workload in repeatable read, but this makes the example a little easier. So let's say I was running my reporting workload on the secondary replica under repeatable read. Now that reporting workload reads a row R1, say in table T1, all right? So it will take a lock, share lock on that row. It is fine, it takes a lock, right? Now, at the same time, on the primary, there is a transaction that comes and updates row R1. So that update transaction will succeed because there is nobody who is holding a share lock on that row, because the share lock is being held on the secondary replica, not on the primary replica, right? So transaction commits, that update transaction log record comes to the secondary, and the redo thread reads that transaction log record, and now it wants to apply that change to row R1. And what happens is it finds, to apply that change, it has to take an exclusive lock, right? And it finds there's a share lock already taken by the reporting workload. With the result, it blocks. Now this could be severe because your redo thread will get blocked for the duration of that reporting query, which could be a long time. That means your RTO impact could be severe. So for that reason, we wanted to solve this problem to eliminate this kind of blocking. So what we have done is, as a solution, we map all isolation levels of the reporting workload. Notice I'm saying reporting workload transparently. So there is no change to the application, there is no change to the reporting workload queries. We internally map those all isolation levels to snapshot. With the result, what happens is we are eliminating any blocking because of readers and writers. So in this example, if I was running my reporting workload under repeatable read, because internally we converted that to snapshot isolation, the reporting workload is not going to take a share lock on row R1. So when the redo thread wants to update that row, it will succeed without any blocking. So this is a good thing. Now, as you know, mapping to snapshot isolation comes with additional overhead, because now we have to create the row versions on the secondary. So let's understand what that overhead looks like. So as I said, we are mapping all isolation levels to snapshot, and row versions need to be created, right? So if you look at the data row before the row versions were created, now if I need to create a row version, I need a space of 14 bytes to set a pointer from my row to the row version. That means your physical representation of the row has to increase by 14 bytes. Now, since the primary and the mirror, or the secondary replica in this case, I'm using mirror or secondary in a synonymous way, have to be exactly same physical storage. So if I need to add 14 bytes on the row, it has to be added on the primary, because secondary cannot make any changes. Secondary is just read-only access. So that means we need to add 14 bytes to the row on the primary. So as soon as you enable secondary replica for read workload, primary starts adding those 14 bytes to the rows that are changed or inserted or deleted, right? All DML operations will add those 14 bytes. That means you will see some impact in terms of storage consumption, and it can potentially lead to some page splits on the primary after you have enabled the read workload. So there is some impact on the primary workload from that perspective. However, there is no requirement that you need to enable RCSI or snapshot isolation on the primary node. this is done under the covers. Your database still is not enabled for snapshot isolation. However, the versions will get generated on the secondary. Since your database is not enabled for snapshot isolation on the primary, there is 14 bytes taken because we need to do that to accommodate secondary, but there are no row versions created on the primary replica. So now let us look at 4 different configurations in this case and see how the row versions are getting generated and where. So in the simplest possible case, you have a primary and you have a secondary. And let's say I have not enabled snapshot isolation on the primary and the readable secondary is not enabled. So it's like a database mirroring kind of a configuration. In this case, there are no row versions to be created, and so there is no extra 14 byte overhead. Now I come and I enable readable secondary, right? In this case, from as soon as the readable secondary is enabled, the primary will start adding 14 bytes to the row shown in this picture by yellow block, and those 14 bytes will show up on the secondary. So the redo thread, when it processes an update, it knows it has to create a version with the previous value of the row. So it will use this 14 bytes and point to the previous version of the row. So the row version in this scenario are being created only on the secondary replica, but not on the primary replica. Now let's take a second configuration where you have enabled snapshot isolation or RCSI on the primary node. In that case, independent of your secondary replica, your primary node is going to add 14 bytes to the rows and is going to be generating all the versions that are needed to run the transactions under snapshot isolation or RCSI. Now, if at this time I enable readable secondary, after it has been enabled for read workload, the redo thread on the secondary will start generating row versions because now it needs those row versions to process the snapshot isolation queries that will be done on the secondary replica. So that's pretty much the impact of enabling readable secondary and the impact of mapping all isolation levels to snapshot isolation. Notice the snapshot isolation removes the blocking between readers and writers for DML operations. However, it does not remove the blocking which you will incur with the DDL operations. So when you run a query, let me step back. When you run a query, say under no lock on a say primary node, when you say no lock, it's just saying that do not take any locks on the data rows. However, it does take a lock on the schema to make sure the schema of the table is not changing. Same thing happens under snapshot isolation. So when I'm running a query on the secondary, in this case reporting workload, under snapshot isolation, SQL Server will take a schema stability lock, schema S lock. So let's say I'm running the query and I got a schema S lock. At this time, at primary, a thread that is adding a column to a table. So I have a statement saying alter table, add column to T1. Now, assuming the reporting query was running on table T1 and it has a schema S lock. So on the primary, that schema S lock was not there because there is no reporting workload running on the primary. So the alter table add column succeeds on the primary. And when this transaction log records comes to the secondary, the redo thread will process it. As I showed in the table here, redo thread will process the DDL log record. It will try to get a schema modify lock, but it will block because the reporting workload has a schema stability lock. Once the reporting workload completes, the lock is released and your DDL transaction will be completed on the secondary. But the challenge here is, again, like the situation before, your redo thread is at the mercy of the reporting workload. It can get blocked for a long time. And as I said, this can be severe. Now, a couple of points note here. First, the DDL is not a common operation in production because typically you will change columns at application upgrade time. However, but if you're rebuilding an index, this could happen. So it happens, but not that frequently. Second thing what we have done is, when that happens is, we will, when the redo thread gets blocked, we will raise an X event to say redo is blocked, and you can monitor that X event and take the corrective action. It could very well be, if redo is blocked beyond certain time, you may want to kill your reader so that redo is unblocked and you can make progress. When we were designing this feature, we thought about killing the redo work, killing the reporting work automatically. As soon as redo is blocked, we'll say, okay, I'm going to kill the read workload, and the redo moves forward. The problem was, if you were running a reporting workload that is very critical for now, or your reporting workload was taking half an hour to run and you were almost like 29 minutes done, and the blocking happens, and if we kill it, it's not a good user story. So what we have done is, we have exposed the right knobs, and we let the customer decide what to do if the redo thread gets blocked. So with that, we feel that the challenges with the DDL blocking, the blocking caused by DDL operations, is somewhat mitigated. So far we have discussed when we run the reporting workload on the secondary, what is the impact on the primary workload, the RTO, and the blocking, and so on and so forth. Now let's look at the performance of reporting workload on the secondary. Ideally, what you want is that if I was running that reporting workload on the secondary, I should have a comparable query plan, same plan or similar plan if I had done the same reporting query on the primary node. Now to explain this point a little better, let me take a simple example. In this case, I'm going to show you a case with a read-only database. So here, I have a database called foo. So I'm going to first drop this database. I drop this database, and I'm going to create this database. And what I'm going to do is, I'm going to create a table, T1. And on this table, I'm going to create a index on column C1, non-cluster index. Now I'm going to insert a row into this table. I insert a row, and I'm going to do a query on this table. Okay, I do a query on select star from this table T1, where the C1 is between 1 and 20. So if you look at the query plan, I look at the query plan, it says it is a table scan. Now this is an interesting point. Even though there is an index available on column C1, SQL Server chose to do table scan. And the reason is obvious, because if there is only one row, there's no reason to traverse the non-clustered index. So optimizer says it will be more efficient for me to go directly and do the full table scan because I have only one row, right? So that makes sense. So now what I'm going to do is, I'm going to insert 10,000 rows into this table. Okay, 10,000 rows have been inserted. And what I'm going to do is, I'm going to make this database as read-only. And you will see why I'm doing that, and it has a sort of an implication on the challenges that we have on the readable secondary. So I'm going to go to the test database. I'm going to look at the properties. I go to the options, and I mark this database as it's read-write data. It's right now read-write database. I'm going to mark it as read-only database. I do, and it has been updated. Now the database is read-only. You can see on the Explorer that it says it is read-only database, right? Now let me use the database test F5 because connection was disconnected. Now if I do the query again, okay? Now notice that I have 10,001 rows in this database, in this table, because I inserted 10,000 rows. So when I look at the query execution plan, it still says it is a table scan. And the reason is, because the database was made read-only, the optimizer, when it was compiling the program, this query, it realized the stats on this query are out of date because the stats are based on one row, but now there are 10,000 rows. I'm going to show you what the stat looks like. So it still thinks there's only one row, and so from its perspective, it makes sense to to do the table scan, right? So it does a table scan. If I show you the statistics on that table, it just shows there's only one row. So this is what optimizer is seeing. It's saying, hey, there's only one row. It makes sense for me to do the table scan. So the key point is, when the database is marked read-only, you do not get updates of the statistics. Okay. Now what I should do, let me just mark this database as read-write. So I'm going to go back to the properties, and I'm going to mark this database as read-write. Okay. I do that. Now, if the database was read-write, and I go back and reuse this database, and I do a query, and if I look at the plan, notice it is choosing the index plan. So in this case, what happened was, optimizer realized that the stats were out of date, and since the database was read-write, it was able to generate the right statistics and did the index scan. So this is the key point. So now imagine, I'm going to go back to my slide. Now imagine on a readable secondary, optimizer comes and wants to compile a query and optimize the plan. It finds the stats are out of date, but it does not know what those stats are. But it cannot really refresh them because it is read-only database. So with the result, it can come up with an inferior plan, and in many cases, that plan could take a lot longer to run on the secondary compared to if that query was submitted on the primary, because on the primary, it could have updated the stats. So the example which I sort of explained in the read-only database context is this. I have a table T1 with 3 columns, C1, C2, C3. And let's say I issue a query with predicate C3 greater than 10. Now, for now, assume there is no statistics available on this column. So when I do this query, the secondary cannot really generate any statistics because it's read-only mode. It will not be able to give you an optimal plan, right? Second example could be that if the stats on the secondary are stale, like the example I showed you in the read-only database context, if it's stale, it cannot really refresh them to figure out what is the right optimal plan. So for those reasons, the query plan that is available on the secondary replica could be very inferior. Now, one question that comes up, hey, what about the statistics that were created on the primary replica? Would they not be available on the secondary? Answer is yes, they will be available. So if I create a stat on the primary, or if I do a query on the primary, those stats do get created on the primary and they will flow into the secondary node. However, those stats could be stale. So for example, if I going back to the read-only database example, let's say I create a table T1 on the primary, I insert a row, and I do a query on the primary. There'll be a stat created on the primary indicating that this table has one row, right? Now after that I insert 10,000 rows on the primary, right? But I have not done any query on the primary. Now I go to the secondary and I do the query, say give me all the rows where C1 is greater than something, okay? Or C3 greater than something. When I say that, since readable secondary cannot really create the statistics, it will use the stale statistics, which is only one row, and with the result, it will generate the inferior plan. So this was the basic challenge that we had with a readable secondary. So the solution that we have come up with is, we will create the autostats just like we do it on the primary, except we will store that statistics on TempDB. So it is not on the user database, because we know user database is read-only, but we will create the statistics in the temporary database. Now, when you look at the catalog view sys.stats, and I have a demo to show you that, it will say that this stat was temporary and this stat is not temporary. And you can look at those stats that got created on the secondary and stored in the TempDB. So that's how we are guaranteeing the query plan that optimizer will generate on the secondary replica will be comparable to the plan it generates on the primary node. Now let's look into a pictorial view of what is going on. This is a picture of secondary replica. The top block shows SQL Server process, and at the bottom, user database is the user database as it exists on the secondary replica, and the TempDB. So let's say I have a table T1, and column C1. The red statistics shown to live inside user database. What it means is this stat was created at the primary, and when the stats comes via log records into the secondary, that stat got created. So in SQL Server process memory, we have, assuming that you have done a query, we have the stat on table T1, column C1. We have the stat on that. Now let's say I insert 10,000 rows on the primary into table T1 such that the stats become stale. Now if I do a query now on the secondary, what we will do is we will generate the temporary stats as shown here in the blue, but the temporary stats will now be living inside TempDB, not in user database. And the SQL Server optimizer transparently knows it has to use the blue stats in this example, not the red stats, right? So that's the latest stat. So it gets that. Now let's say I run the same query on the primary. Now when I run the same query on the primary node only knows about the red stats. It does not know about the blue stat because the blue stat was created on the secondary and that is only visible to the secondary. So it creates the red. So what happens is when I run the same query on the primary replica, it will create the new stats. And I'm showing that stat as the yellow stats. So when that stat flows back into secondary, in that case, the SQL Server, optimizer will know that I need to use the yellow stats because that is the most latest stat, and it will hold that. Now what happens with the blue stat? I mean, as you can see, the blue stat is not really needed. We don't automatically drop it, but we provide you can use drop statistics command in T-SQL to drop it if you want, right? Other thing to note is if, for example, your secondary replica is restarted, all the stats that you have in the TempDB gets lost. It's not a big deal because the auto stats are generated based on sampling. It's not very expensive to create. So as when you restart your secondary and you start submitting queries, any stats that it finds missing or stale, it will automatically generate them. Now let us look at a demo on how these statistics are working. So I go back to my demo, and what I'm going to show you is a primary database. And on the Explorer here on the left side, let me just show you that the database, the instance 6PL LHSI is a primary replica, right? So this is my primary replica, okay? So what I'm going to do is I'm going to use my database that has been part of availability group. I drop the table T1, and then what I'm going to do is I'm going to insert a row into this table, and let us look at the stats at this time in table T1. You will find that there is no stats, and the reason is just because I inserted a row, SQL Server will not automatically create the statistics. It will only create the statistics when you do a query. So I go and let's say I run a query. I do a query, and now if I look at my stats, it shows there's a stat on column C1. And notice the name of the stats. This shows that this was a internally generated name. So this is an automatically generated statistics. Okay. Now what I'm going to do is I'm going to do a insert. I'm going to insert 10,000 rows into this table. I insert 10,000 rows. By inserting those 10,000 rows, obviously the stats have become stale. If I do a query, it will sort of create the new stats, but I'm not going to do that here, okay? Now I'm going to go to my secondary, okay? Secondary is on instance YLZ, or let me just show you on the Explorer. It will show you that this is a secondary replica, so it is a secondary replica, okay? So I go there, and let me do this. I go here, I use the database, and before I do anything else, let me try to create a database, right, or table. It fails because the secondary database or secondary replica, you cannot really make any changes to the database, just to show that this is read-only. Now, if I look at the stats here, okay, when I look at the stats, notice the stat that I had created on the primary still shows up here, right? Which is true because anything that you make changes on the primary via log records, it will come to the secondary, okay? Now, if I do a query on column C2, now I had not done a query on column C2 on the primary, so that means those stats are missing. So when I do this query, and now if I look at the stats, you will see that a new stat has been created on the secondary. This stat does not exist on the primary, right? I can go back to primary and I look at the stats. This is the primary, okay? And I'm going to show you the stats on the primary. It still has one stats, right? Going back to secondary now, it shows two stats. Now the interesting thing is, I'm looking at sys.stats catalog view. If you go here, it says there's a new column is temporary. It says the first stat is not temporary and the second stat is temporary. So to me, it means that this is a temporary stat. And what we have done is we generate a special name for the stats that are temporary. We sort of append underscore read-only database statistics to all auto-generated statistics that are stored on the secondary, right? Now let me do another query. I'm going to do a query on C1, okay? Now this query on C1 will find out that the stale existing statistics that was created at the primary is now stale, right? When I do this query, and if I go and look at my stats, you will notice even that has become temporary. Why? Because when I ran this query on the secondary, it knew that the stats that I have is stale. So it recomputes the statistics to make it up to date. This is like the example I was showing you, that red stat became the blue stat. So this is the stat that got created on the secondary. This is updated. Now if I want to drop some stats, right? So in this case, I know this is my temporary stat. And let's say I want to drop it. Okay, I copy it. I go to a command to say paste. I'm going to drop it. Okay, so I go here and it is dropped. And if I look at my sys stats on the secondary, on the table T1, let me just do that. You will notice I have dropped one of my temporary stats. Okay, so this has been dropped. So this is how you can see how the stats are being managed on the secondary replica. Now, the space taken by stats on the temporary database is not a whole lot, because each stat typically takes one log page, so say 8K. So if you have, say, 1,000 statistics or 5,000 statistics, at most you're taking 40 megabyte of TempDB. So what you need to do is you have to configure your system to accommodate the space needed for storing the temporary stats. So that's all I wanted to say about this demo. Now let me talk about the connectivity. So when you have a secondary replica, you can choose to say that no read workload is allowed. This is like a database mirroring configuration, right? So you can say in secondary role for this replica, I will not allow any read workload. So when you know, this is a default. There are two other options. You can say I will allow read-only workload, or I will allow all workload. And let's look into why we have these two options. Okay. So it is clear that you can only run a read-only workload on the secondary. You cannot really run a read-write workload. So if you have set up your readable secondary to say that I only allow read-only workload, the connection that the reporting workload has to give should have a property, it's a new property on the connection called read-only intent. So you need to say that this connection is read-only intent. So then when it comes to the secondary replica, and secondary replica is configured to accept only read-only connections, it will accept that connection and that connection will be successful. Now the benefit of that one is, if you were by mistake, right, connected a non-read-only workload to the secondary replica, and for that you did not set the intent to read-only, it will deny that. And what happens is this makes the customer story a little better in the sense there is no surprise. It's not like I was able to connect my workload to a node in always-on topology, and after a few minutes or after some time I find out, oops, I connected to the readable secondary. I should have connected to the primary node. So you can use that connection property to avoid surprises. There is another benefit of that. Notice there is another option called primary role. In the primary role, that is in a replica that you have, could be in two roles. It could be a secondary, right? Or it could be a primary. So when the replica is in primary node, I can say allow connections read write or allow all connections, right? So if I have configured my primary replica to say only allow read write connections, okay? Now if I was submitting a connection, a reporting connection, which says my intent property is read only, and if by mistake it connects to the primary, right? I mean, you can always manually connect to a node. So if it connects to the primary, and the primary has been configured to say I can only entertain read-write connections, so what will happen is primary will deny the connection to this reporting workload because it says read-only. So this again prevents some surprises to the customer where some customer by mistake or some user by mistake connected to the primary thinking it was secondary. So those are the key benefits. But if you had an older client, so it does not have, older clients do not have this new property, read-only property. If they need to connect, then you have to configure your readable secondary with the option all. In that case, it will apply, you can have any client connection with any lower version of TDS, it can connect and it will be able to run the reporting workload. Now the challenge is, now even if you can connect a read-write workload to readable secondary, it will allow that, but of course when you do the first DML or DDL operation, it will fail. So that's a key benefit. So in terms of application connectivity, as I said, there is a new application intent called read-only. It's a new connection property, and example shows this is how you will specify. Now one interesting thing about read-only property is, if you are connecting your reporting workload through read-only property, AlwaysOn will automatically direct that reporting workload to the right secondary. So for example, if you were running, say, in a 5-node topology where there is one primary and 4 secondaries, and for argument let's assume all 4 secondaries allow read workload, when you connect, it will figure out which readable secondary it has to go to. And let's say that the failover happens and that readable secondary becomes a primary node now. Now when you reconnect, it will know not to go to that primary node, it will go to another readable secondary. So that's the key benefit. So you will, the reporting workload has to be, is completely oblivious of where the readable secondary is. The system, the read-only routing will take care of the fact of knowing where the secondary is and will direct your connection to that. So with that, I wanted to summarize this presentation. First, readable secondary offers a better hardware utilization. So instead of staying with 5% of CPU and 75% of I/O, you can use those cycles, 25% of I/O, you can use those cycles to run your reporting workload and use that bandwidth. And as Kevin will talk in the next presentation, you can even use those things to offload your database backup. By moving your reporting workload to the secondary, you give a lot more resources to your primary workload, so you will see performance boost in your primary workload. And since your reporting workload is running on the secondary without any primary workload there, so you may see even performance gain over there. So it's like a win-win situation. Your primary load is going to perform better, your secondary is going to perform better. And a key point is, from a performance perspective, your reporting workload should see very comparable query plans. And I already explained to you about the impact on RTO, the recovery time objective, by running a reporting workload. In many cases, we expose right tools like resource governor or X event when the redo thread gets blocked. You can manage those things to make sure your AlwaysOn is running smoothly with the and meeting the demands of your workload in terms of the recovery time objective and recovery point objective. And AlwaysOn topology is very easy to manage. There is a dashboard. You can monitor the dashboard. When the redo thread gets blocked, you will see it is not making any progress on applying the transaction log records. At that time, you can take the corrective action by looking at why it's so, and in this case, kill the read workload that is blocking the redo thread. Well, thank you so much for joining, and have fun with AlwaysOn. Thank you.